I said to you last Friday, I believe it was, we have to we'll be through a whole lot of material in this last, counting today, we have 16 days of class time to cover a lot of material. So you need to not only be worrying about making sure you understand what we're doing here in class together in notes, but you're also making sure that you are doing some extra reading in the textbook on your own and making sure that you really are learning the material because it will be on the final exam. So our learning goal today, I can find the zeros of a quadratic function. The zeros play a huge role in a quadratic function, so we have to make sure we understand them. And we're going to find them from the graph. And then I can find the axis of symmetry of a parabola, and we've already talked about the axis of symmetry. So the zero of a function, let's talk about that first. When it refers to the zero of a function, it's really asking you for the x value. So let's circle that. It's the x value, not the y value, the x value that makes the function equal 0. So in other words, the y value is 0. So what is the x value that when you put it into the function, it outputs a y value of 0. It is called the zero of the function. So when we say zero of the function, you're going to want to mix that up and say, well, then x equals 0. No, x equals whatever number makes the function equal 0. For a quadratic function, there can be the possibility of 2 zeros. So there can be 2 different zeros. There could be just 1 0. Or it can turn out that there actually are no zeros. There are not any x values that will make the function equal 0. To find them on the graph, well, where are all the points where the y value is equal to 0? On a coordinate plane, where are all the points, where are all the ordered pairs where the y value is equal to 0? Where are those at? Look on your graphs, if nothing else. Use assignment 124. Where are all the points located on a coordinate plane that have a y value of 0? On the x-axis. Yeah. Any point on the x-axis has a y value of 0. All those points, wherever a graph crosses the x-axis, that is called the x-intercept. So we are going to look for where is the graph crossing, and we're going to put a /s. It could be either one x-intercept or it could be 2 x-intercepts. Or maybe there's none. Maybe it's not crossing the x-axis at all. But we're going to look for where is it intercepting the x-axis. What are the x-intercepts of that function? Okay, so on page 531, I want you, first of all, I want you to study through example 1 on your own just for a bit. I want you to take a look at that. Example 1, middle of the page, 531, finding zeros of quadratic functions from graphs. There are 3 graphs there, A, B, and C. Avery, how many zeros are there for the quadratic function graph in A? None. There are 0. Why are there 0 zeros? Why are there no zeros? It doesn't cross the x-axis? Really? In example 1A, in the example? Is that what I told you to do? Is to check it out? Did I tell you to read through the example? I have a feeling you might have been in the wrong spot. Okay. So let's get to the right spot. How many zeros are there? How many places is the parabola crossing the x-axis? 2 places. So there's 2 zeros for this one. What are they? There are actually -1 and -1 and +2. And notice what they did. They put them into the quadratic function, both of them, and checked them out to make sure that they make a y value of 0. That's exactly what we will do also. We will verify that they do make the function equal 0 because it may look like they're crossing there, but we want to make sure that it's exactly those values. How about in B? How many many zeros are there? There's only one. Because what is that point that's sitting on the x-axis called? We learned that on Friday. What's that point called where the parabola makes its turn? The what? The vertex. Yeah, it's the vertex. So when the vertex is on the x-axis, there's only going to be 1, 0. And then in C, that parabola does not cross the x-axis, does it? This is one of them that does not have any zeros. So now when we look at the check it out problem below that example box, 1A, we have the parabola that, as Adri said, doesn't cross the x-axis. So it does not have any intercepts. So because it does not touch or cross the x-axis, we would say there are no zeros. We don't say the 0 is 0. We say there are no zeros. There are no x values we can substitute in and get a y value of 0. How about in 1b? What's happening in 1b? The parabola is touching the x-axis at what? Chase? Ordered pair what? 0, 1? 1, 0. You guys agree with that? In 1b, that it's touching the x-axis at 1, 0? How about 3, 0? Thanks for joining us now, Chase. Okay. 1b, check it out, is touching the x-axis at ordered pair 3, 0. So it appears there is only 1, 0. And it is what? What is that 0? It's the x value that makes the function equal 0. So it is 3. The x value that makes the function equal 0. So it is 3. So now we're going to check it out and see if it really does. So if the 0 is 3, we should be able to substitute into this, and our y value should come out to be 0. Now, many of you are going to do a lot more than you did on that graphing assignment. Just show this step and that's it. You're going to show the following the order of operations and getting the values and not letting your calculator do everything for you. Okay? So we can square 3. What is that? 9. We can take 6 times 3. What is that? 18. Add 9. What is 9 take away 18? Negative 9. What's negative 9 plus 9? 0. It checks out as being a 0 because it made the function equal 0. So when there's only 1, 0, what do you think we can always say? If there's only 1, 0, what will be true about that quadratic function's graph, parabola? There's only 1, 0. If there's only 1, 0, it can only touch the x-axis in one spot. When will it only touch the x-axis in one spot? When it's the vertex, that's right. If it is, when there's only 1, 0, it is the vertex. You're going to take the x value from the vertex, and you'll have your 0. When there are 2 zeros, let's look at our assignment number 124. How many parabolas do we have on that assignment? 6? I think we have 5 because the first one's linear, isn't it? We have 5 of them. How many zeros do those guys have? Are there any that have no zeros? Remember, for there to be no zeros, what has to be true, Riley? For there to be no zeros, what has to be true? What has to be true for there to be no zeros? This Benton doesn't cross the x-axis. Are there any of those 5 that do not cross the x-axis? 2 through 6. No, they all cross, don't they? I made everybody get it right, so you all should have the same grasp Okay, well then that means there aren't any on that assignment that had no zeros. How about 1 0? Are there any of them where the vertex is sitting on the x-axis? No. So none of them have just 1 0 either. Well then that means all of them have to have 2 zeros. They should all be crossing the x-axis in 2 different locations. Now, that does not mean necessarily that your parabola, you have points on the x-axis. Do you? Does that mean we can't have zeros if you don't have points there? No, you were given x values to help you make the graph. How many points does that parabola really have on it? How many ordered pair points are there really on a parabola? Just 5? Or maybe 7? Pardon? How many are there? How many points are on number 2? How many points are on that parabola? How many? 7. Okay. Now we used 7 points to graph it. How many points are there really on that parabola? Oh, okay, well let's go back to number 1, linear. Maybe we can remember back from linear, maybe. Number 1, how many points are on that line? An infinite number. We used 4 points to graph it, but there are an infinite number of points on that line. It's going to be maybe hard to pick out what some of those ordered pairs are, but there are an infinite number of points on that line. So then tell me how many points are on the parabola in number 2. Not just 7. An infinite number. Every point that helps make up that curve. There's a whole bunch of other points between all those other points that we actually graphed to help us get it. So there's an infinite number of points. But each of those has 2 zeros because they cross the x-axis in 2 locations. One of those problems, you can clearly, very obviously tell what the zeros are by either looking at the table or looking at the graph. Tell me which one that is. I mean, you are so convinced that you know what the zeros are. You are willing to bet me $50. Number 3. You agree with Macy? Number 3? Who did? Oh, Emma, sorry. So, Emma says number 3. How many of you agree with her that number 3, you can clearly tell what the zeros are? Oh, some of us are kind of thinking we might could agree with her and others not so much. Look in the table for number 3. Are there any times where y is equal to 0? When x is what? 0. So one of the zeros is 0. And what's the other 0? Negative 4. When the x value makes the y value equal 0. This is huge. This is important. You need to understand this. The x or the x values that make the function, the table, in the table the y values are 0. Where that parabola crosses the x-axis, those are considered the zeros of the function. Okay? So, in number 3, we can clearly tell what they are. Are there any others we can clearly, right now, you're convinced you could bet me $50 on it? Number 2, 4, 5, or 6? I don't think you probably want to risk it. They're going to probably not be a whole number or an integer value. They're probably going to be a decimal or a fraction value, so you might not want to take the chance that you're going to be able to get it right. Okay, well, when there are 2 zeros, so like all of these have, the x value of the vertex is halfway between those zeros. And that's important because we sometimes have to be able to tell what the vertex is, and when we know the zeros, that will help us do it. Could you tell me right now what the vertex is in number 3 on this assignment, 124? What's the vertex? What's the vertex in number 3? -2, -4. Would you look in that table? I want you to start observing something because we're going to graph tomorrow again, and we're not going to graph using a table, but I want us to be able to see what's happening here. When y is equal to -4, x is equal to -2, tell me something about the y values on either side of -4. What's true? they're the same. Then you go 2 away and they are the same. And then you go 2 away again and they are the same. Every point except the vertex has a point symmetric to it. There are 2 points on a parabola that will share the same y value. Another 2 points that will share the same y value. Another 2 points. There are lots of points that will have another point symmetric to it that will have the same y value. The vertex is the only one that will not. So, what are the zeros? What did we decide the zeros are of this function? Number 3. What are they again, Chase? Nope. We're back on 124 now. See, you know, come on. Join in. Half time's over. What are the zeros in number 3? What did we say? 0 and -4, right? X is equal to 0, x is equal to -4. What's halfway between those two? -2. Is the x value of the vertex -2? Yes, it is. So halfway between, the vertex should always lie halfway between any 2 x values. It should, and so when we want the zeros, when we want the vertex, we can look for the zeros. Okay, let's go to the back side. Let's see if we can remember this from Friday. A vertical line that is imaginary, that divides the parabola into 2 symmetrical halves is the vertical line that divides the parabola into 2 symmetric halves is the axis of symmetry. Every parabola has an axis of symmetry. Axis of symmetry. It's an imaginary vertical line. It's a line we can draw. When we do draw it, we typically draw it as a dashed or a dotted line just to show it. It will always pass through the what? What do you think has to happen for every parabola? That axis of symmetry that divides that parabola into 2 symmetric halves will always have to pass through what? The vertex. The vertex will be on the axis of symmetry. Every other point that makes up the parabola will be on either side of that axis of symmetry. You can use either the vertex or the zeros to find the, I don't remember what that is. I lost my place. Oh, to find it. Okay, so this is, we're not filling anything in here. You can use either the vertex or the zeros to find it. By the way, a vertical line has an equation. Anybody remember what's true about the equation for vertical lines? Which variable is missing in the equation? Are there y's in the equation of a vertical line? No, there are only x's. It's x equals a number. So when you are asked to find the axis of symmetry, it is, let's put this over here, it is an equation. It is not just a number. It is x equals some number. It is an equation, the axis of symmetry. You are not going to just write a number down and say, here's my axis of symmetry. You have to show that it is a vertical line. And so you have x equals a number. And if we can't find it by looking at the graph or finding the vertex or the zeros, we use this little formula. X equals negative b divided by 2a. And we're going to use that a lot. So get it memorized. Okay, now we're on page 532. Check it out. Let's go over to page 532. Okay, so it says at the top of the page there, finding the axis of symmetry by using the zeros. Well, if there's only one zero, then you just need to find the x value of the vertex, because it's, remember, the axis of symmetry is going to cross right through it, and we can take the 0 from the vertex on the graph. If it has 2, we can find the middle, or we can use this little formula. So let's look at 2a down at the bottom of the page. Find the axis of symmetry of each parabola. 2a. How many zeros are there? There's only one. What is it? Negative 3, 0. So the 0 itself is what? Negative 3. When there's only one 0, that 0 is actually the number that x is set equal to, because it is going to cross right through that vertex. So in this one, the vertex is at negative 3, 0. Therefore, the axis of symmetry is, let's circle that, x equals what? Negative 3. A vertical line would be drawn going through that vertex, and it is 0, so we already can see what it is. We're going to write our equation x equals negative 3. Okay, 2b. Will you identify the zeros in 2b on your papers, please? What are the zeros for 2b? Apparently there are 2 of them. So what are they? Negative 2 and 4. So when we can tell what the zeros are, but we can't really tell, can you tell what the vertex is for sure? It's, you know, you might have a good idea of what it is, but are you certain? I'm a little more certain about what the zeros are. How about you? They're plotted right on the x-axis. So we're going to find the x value halfway between. So negative 2 plus 4 divided by 2. Add your zeros together, divide by 2. It should give you the halfway point between them. So what is negative 2 plus 4? 2. What's 2 divided by 2? 1. So the x value halfway between those zeros is 1. Would you agree, looking at your graph, that if you counted in, would you land on x equals 1? Okay? So the axis of symmetry then, again, we have to write it as an equation, is x equals 1. It's a vertical line that would cross through that graph at ordered pair 1 something, the vertex. We just don't know what that y value is right now. Well, if a function has no zeros, or even more importantly, it's hard to identify them from the graph, we need to use that little formula that I just introduced to you on the front side, x, or somewhere, maybe it was up here, right here, x equals negative b over 2a. So let's go look at number 3. Check it out on page 533. I'm leaving all the rest of this reading for you to do. We're just going to go to the check it out. Find the axis of symmetry of the graph of y equals 2x squared plus x plus 3. Hey, is there a graph there for us to look at? No? What if there was a graph, but we still were, like, I want you to look on assignment number 124. Remember we talked about, you probably would want to bet me $50 to tell me what the zeros are in number 6. You want to tell me what the zeros are in number 6? So that then you can tell me what the axis of symmetry might be. Anybody think they could tell me what the axis of symmetry is for number 6? On assignment number 24. What do you think the axis of symmetry is? Emma? What number are we on? 3. Nope. Well, I have a lot of daydreamers today. A lot of daydreamers today. I don't know when you're going to learn this material. In number 6, on assignment number 124, can anybody tell me what the axis of symmetry is? What you really believe it might be? Pardon? 1. X equals 1, do you mean? Yeah, that's what I thought you meant. X equals 1? How many of you think you could agree with Austin? X equals 1. Yeah, it's got to cross through the vertex, and the vertex is ordered pair 1, negative 7. So the axis of symmetry would be x equals 1. Well, what if, though, we don't have a graph where we can't clearly tell from the graph? All they did was give us an equation. We're going to identify the a value, which is what for this one? 2, and the b value, which is 1. By the way, can you have a b value of 0? Yes. Can you have an a value of 0? No, you can't have an a value of 0. So
So we're going to substitute into our formula. We're going to say x equals the opposite of negative. We'll put our b upstairs and 2 times 2 downstairs. Well, that becomes a 4 downstairs. So basically this is our axis of symmetry right here. X equals negative 1, 4. That would be very hard to tell from a graph. That it was crossing, it was going through the vertex's value might be negative 1, 4. Do they have another one for us to do there? No, they don't. Okay, let's go take a quick look at your homework on page 100 or 535. Let's go just flip over to there. Right now I'm not asking you to get out your list of paper. I'm asking you to look at your book with the assignment. We're starting with problem number 3. It says find the zero of each quadratic function from its graph. Check your answer. How many zeros can there possibly be? 2 or none. Yeah. So can you check it if there are none? No, you would just say no zeros not crossing the x-axis, right? If there's only 1 0, then you have only 1 check problem to show. If there are 2 zeros, then you have 2 check problems to show. You have to show both of them being substituted in and getting your y value to 0. What does the directions say for the next step, Chase?
40 quadratic.
No.
Oh, find the axis of
Parabola. Okay. Look at number 6. Which method do you think you're going to use for number 6? From our notes. Let's look at our notes. What did we do for axis of symmetry for a problem like this? Anybody remember? No, not for this one. We don't know what B and A are in this one. Do we know what the zeros are? Yeah, so Benson, what did we do? Number 6, find the axis of symmetry.
To add the x's together.
We would add the x's together like we did here, the zeros together, divide by 2, and we get our axis of symmetry. How about number 7? Same thing. How about number 8? Yeah, that's like 2a, isn't it? We say, well, the vertex is this, so then the axis of symmetry has to be this. Okay? Okay, now the next set of directions say for each quadratic function, find the axis of symmetry of its graph. 9 through 12. What do they give us? The equation. So what's the only way possible to find the axis of symmetry? Using x equals negative b over 2a, like we did down here in number 3 on this side, okay? So we're 19 through 28, I'm going to guess it's just kind of a repeat again of what we were just doing, okay? So make sure that you are using your notes to help you out and you're showing enough support for all of your answers, okay? Anybody have any questions at the time? And again, study through the lesson on your own because you need to know how to do this.